solving high-dimensional design problems is pretty hard. Some people say, understand the hardware. Others say, understand the data. Others say, understand the problem. In real life, the design problem is highly dimensional. We've got algorithmic choices, decomposition choices, compile time offloading choices, spatial layout of our stuff in memory, execution, vectorization, caching, and handling random access. But we've got to do all this in the context of the problem domain too. We can group these into logical, algorithmic type decisions, physical, spatial, temporal, techie kind of decisions, and problem domain decisions. And you can make really, really slow systems by screwing up just one of these. Next. So we're going to try and solve the design problem with a little help from a mathematician called George Polya. George wrote a wonderful book called How to Solve It, where he wrote down his work on solving problems, mostly mathematical problems. Next. His approach was a four-step problem. First of all, he suggested that we understand the context of the problem, not just the problem, and restate it, she's a hero, and restate the problem clearly. And the next bit was to devise a plan where we look at analogous problems and the tools and techniques that we've got, collect those together and work out how we're going to attack the problem. Finally, we're going to execute our problem, and the last step is to reflect on how well we've done. Well, we're doing well now. Next. So, understanding the problem Pólya style, in this case, the unknown is the final design. The data is the information that we're using to construct the system, and the condition is the requirements. It's good if the requirements are satisfiable. Can we separate the requirements into separate conditions and write them down? The next bit he certainly recommends is draw a diagram. I love this bit. First one. This is Clerk Maxwell, Richard Feynman, Leo da Vinci, kind of bright guys. When they're struggling, they draw pictures. Next one. And these two also, Newton and Einstein. So should we draw pictures when we're thinking? Yeah. Next. Moving on to devising a plan. Again, it's a collection of sort of, it's phrased in mathematical speak, but we're translating it to our domain of designing software. A look at the unknown. In this case, in his book, he's really getting at, look at the end before you start, know where you're going. Have we seen this problem before? That's a great one if we've solved it before, because we don't need the rest of the talk. If we haven't, do we know a related problem that we can look at? Next. We're going to try and, if we can't solve the one that we're working on, can we try and solve an auxiliary problem? By relaxing the constraints, if we can get something that's a bit easier and vary the problem, we might actually get a bit of a breakthrough. And the bulk of his book is about various thinking tactics, heuristics, reasoning by analogy. If our analogy mapping is really, really tight, one-to-one with another problem, we can actually call that a reduction and say, transform our hard problem into a graph problem, solve it in the graph problem, and get the answer back into our original space. Decomposition and reassembly is we break the problem down into smaller problems and then use those smaller problems and build them back up into something completely different, which we can solve and see if they're helpful. Generalization and specialization is also good. Yeah, go on then. We execute our plan diligently. We don't want to screw it up. And finally, number 4, we reflect on how well we've done. Finally, next. He found through experience of watching his students use these techniques, most of the guys and girls would screw up because they didn't put enough effort into solving the understanding the problem initially, but also they could also fail by planning failures, not actually devising a good plan. Execution failure due to carelessness, well, that can happen. Next. Socratic questioning can help. Asking good questions can help us get good answers. Next. And key elements of success are having a good positive mindset to keep going even in tough times. And finally, Yeah, feeling stuck is natural. If we think about it, most of the time we're stuck. We have about a whole minute or two a year of aha moments, and the rest of the time, us being stuck. So it's okay to feel stuck when you're working on hard problems. Thank you.
Thank you.